So, hello guys, back to the second part, and in this part, we will see the implementation and we will also see the DP approach. And, guys, one thing that I would like to say you that since I'm using a free software, then so as a result, I can only record for a max of 15 minutes. So, I won't be coding, I will explain you each and every step of the code, but I will just go through the code because if I explain the whole code, then it would take a lot of time. Thank you. So think it in a DP manner. So for DP, everyone might now think that there are two possible cases. Like you can have either DP from I to J, something like this, or we can have a 1D DP table, DPI. So, what I am telling you guys to think what can be your DP of I. So, DP of I will denote the maximum value that Ayush has achieved till I time. Are you getting this, guys? Is it making any sense? I think it is. Like DP of 1000 will denote the maximum value or the maximum amount that Ayush has achieved till 10 a.m. since 1000 will be 10, like 10 a.m. So we will have a DP table of size 2400. Now why 2400? Because from 1 to 2400 it will cover all the minutes. Okay, so DPI will denote the maximum value that Ayush has achieved till the IAT time. Okay, now some of you might also get confused, like which to use, like 1D DP table or 2D DP table. Now you guys only think like we can also use 2D DP table. Here it will be like will denote the maximum values Ayush has achieved, or Ayush can achieve between I8 time to J8 time. And our finally the answer would be, if we use the 2D DP table, answer would be DP of 1 to 2400. But this solution won't be much efficient in both time and in both memory constraint, because we need to make a DP table of 2400 and 2400, and it is not really a really good practice to use such large memory. Max, I think 1500 to 1500 still you can use because of the constraints and the limit that the compiler, that the online judges have. If you can see right here, the memory limit is up to 56 MB. Okay, so we won't be using the 2D DP solution. We would be using the DP 1D DP solution. So now I think you guys have understood like what our DPI is holding. Okay, so what our DPI is holding, maximum value Ayush can achieve till IAT time. So if I need the maximum value the Ayush can achieve till IAT time, I would also need all the jobs finishing at the IAT time, like all the jobs that are finished till the IAT time, or all the vouchers that are expiring at the IAT time, so that I can decide from among those jobs, uh, so that I can decide from among those jobs or those vouchers which to pick and which not to pick. Okay. So, but in the input you can see the input won't come according to our need. Input would come in a random order. So we need to sort the input. How do we need to sort the input? We need to sort the input in terms of the ending time. Are you getting this, guys? Like if you simply apply the sort function, it would sort, like if you like if our job is something like this, 1 comma 20, and another is I think 20, let us say 10 to 15. Okay, take it like that. Just take it for, just assume. Now if I just apply the simple sorting function, it would see the first value 1 and it would compare it with 10. Then it will just keep it in the same manner, like according to the starting time, it will sort. But if you see, like if you are iterating from 1 to 2400, then 15 should have come first, because dp of 15 will be should have been calculated before we are calculating dp of 20. That is what dp is all about. Like if you know dp of 15, and you know all the processes that are going to end, and sorry, all the vouchers that are going to expire at the 28th minute, then you can easily calculate the maximum amount that you can have till the 28th minute. So I think this is clear for you guys. The main thing that I am saying is that we need to sort the input given in terms of ending time, and I have explained you why we need to do that. Because in order to use this, I will need first all the jobs ending at the I time, then only I can calculate the dp of I plus 1. If I have the dp of I, then I can easily calculate dp of I plus 1. Yeah. So see here in the code, ignore this first. See, in the code it is written right. It contains large test files. Fast input and output is recommended. So this is basically the fast input and output. And how do you know it? If you easily search like uh, gfg here, and you just type this one, fast io, you will get fast IF for competitive coding. You can just copy paste these two lines from here. Okay, so now here I'm taking the input n. So now we are creating a 2D vector. It is a vector of vector, and it is basically a constructor call. It will initialize the main v with n jobs. Okay, like n jobs would be there, and for each array, like it's a 2D array, we will have the main array would be of size 3, and I'm just taking a garbage value. Like if the okay, let me explain you guys what is this. If the input comes as 3, what will my v contain initially? My v will contain, that is a vector of vector v, it will contain this. This is saying to the compiler that I would be needing n vectors, and each vector should have size 3, and every value, and the value should be initialized to 0. I think this much is clear. Now this is just I am taking the input. Okay, this is just taking, I'm just taking the input here. Now here I have initialized my dp array, long dp, and then I am just setting the value to be 0. Now here comes the main part, sorting part, which I was telling you. Like why do we need to sort the input? We cannot use input as it is come, just as it is given in the question. So we need to sort the input by the ending time. Like even if the job, like here, if I again take the test cases, like just take this test case. Okay, here. Okay, here so it's already sorted according to the ending time. If you see, it's 10:30 to see if this job was first and this voucher was second, then we need to sort to the ending time. Okay, so how to sort with the ending time? We will have to use the custom operator, or you can say the custom sorting. So this is the custom sorting function that I have passed, and it would take two vectors. And how to sort them? If the ending time, like I want this relation to be true always. Like if my ending time of the I plus 1th voucher is greater than the ith one, then I am happy with it. Then I am returning true. Okay, this is what I want. Else return false. Okay, okay. Now let's come. I will just explain you this part now. So, in order to calculate DPI, first I would need to take, consider, in fact, not take, in fact, consider all the jobs, all the voucher. I'm keep calling this job because actually I think ignore the job, you just replace it with the voucher. First I would need to consider all the vouchers whose ending time is I. Now you will see the beauty of the solution. Okay, so what would my dp of I, like if my job I comes, if a certain job comes or certain voucher comes, okay, this is the voucher V. Its starting time is S, ending time is, and it's giving me a profit of something like X. Profit is X. So what would be my DP of I? DP of I would be maximum, because I will explain you why I am taking maximum of DP of I, because see there can be multiple jobs ending at the same time. So first they can be this can be voucher V1, again again as the again another voucher might come V2 with the same ending time. So we will be calculating dp of E, like dp of this ending time. Okay, like dp of I. What does dp of I? Dp of I is basically the ending time, right? I is the ending time of that jobs. So for calculating the dp of I, we need to consider all the jobs which is ending at the I time. So dp of E is maximum of dp of E. I've already explained you why I'm taking this maximum, because there can be multiple jobs. So if we have already calculated dp of E, now we have to just store it, and we won't take every other cases. Okay, like, so that's why I've taken maximum of dp of I. Or one case could be this one, we ignore this job. I've told you in recursion also in my previous video, either you take it or you don't take it. So we don't take this job. Okay, so my maximum would be dp of E minus 1. Or maximum, I take this job. Now if I take this job, what profit will I gain? I will gain X profit, because it is giving me X profit plus dp of E minus, okay, dp of S. dp of S, I think you guys understood. It would be dp of S minus 1, because it's inclusive, right? Like if I am taking from 10 a.m. to 12 p.m., then my maximum profit at 12 p.m. would be profit X plus the maximum profit that I have attained at DP of 9 comma 59, or 9:59 minutes, like 1 minute earlier to my to the 10 a.m. Okay, let me again explain you this thing. Suppose voucher V1 comes and the starting time is 9 a.m. and the ending time is 10 a.m. Profit is X, right? Profit is X. Again, voucher V2 comes, starting time is 9:30 a.m. Okay, the ending time is 10 a.m. Same ending time. Profit is Y. So what would be my DP of E? And only these two jobs are ending at E. Okay, so what would be my DP of E? DP of E, see, that's why I've initialized my DP of E to 0. Okay, so initially DP of E is 0, and DP of E, if I don't take this job, like DP of 10 a.m. would be, I don't want to take this job, so DP of 10 a.m. would be DP of 9 comma 59. I'm not interested in doing this job. Okay, I'm not interested in doing this job. But if I do this job, I'm getting a profit of X plus DP of starting time minus 1. Since this is covering from 9 to 10 a.m., I cannot have any other voucher in between this time. So, in fact, I cannot have any voucher ending at 9 a.m. also, because it is saying it, because the question has already mentioned that both time would be inclusive. So that's why if my voucher is starting at 9 a.m., then I have to consider DP of starting time minus 1. That is 8 past 59 minutes. Okay, I think this is pretty much you guys must have understood. Okay, so this is only what I'm doing in my code. See, now first I'm iterating from time, iterating from time 1 minute to 24,000 minutes. This is pretty much very clear. Okay, now this is my index j. This is index j has been assigned to 0, like it is indicating to the first event, okay, or the first voucher. So while my j is less than n and my vj of I. Now what is vj of I? It is the ending time of the j job. You can see, right? uh, like the zeroth index will contain the starting index, sorry, the starting time. Okay, here the zeroth index will contain the starting time. Okay, the first index will contain the ending time, and the third and the second index will contain the value what we have been received as the input. So now if the particular job has an ending time less than or equal to I, okay, so we are calculating the starting time, the ending time, the profit, and what would be by my dpof? Dpof will be maximum of either you either it is a maximum of the previously calculated value, okay, and dp of e minus 1, either you don't do it or you do it, and then the dp of s minus. I have already explained this line to you, and we would increment our j as this job has, as now we have already considered this one. Okay, and now why this line? Why I am taking dp of I is equals to maximum of dp of I and dp of I minus 1? Because suppose the ending time is 10 a.m, 10 a.m, and next starting time of any voucher is 11 a.m, and it is ending something around 2 p.m, 3 p.m. Okay, now now what between 10 a.m to, now what is between 10 a.m to 11 a.m? What would be the maximum value attained at 10:30? 10:30 will say, 10:30 will say, since there are no jobs ending at 10:30, maximum value would be at, that I am getting would be at 10:29. And now what will be 10:29 say? 10 to 10 10:29 will again say, since I'm also not getting any job, so my profit will be as same as 10:28. So if it is already calculated, then we are again calculating the max value. Or if there is no job ending at a certain time, then we will just take the previous ending. Okay, I think this is self understandable. Because okay, so our answer would be answer equals to answer max of, again we are iterating and we are calculating. We don't need this statement also, because you have already calculated this line. So even if you remove this one, and if we just write dp of 2400, it would still work. Okay, now let's just compile our code. I've already received an AC, so this will work. See, every test case has been passed. The total 10 cases. So thank you guys for this video.